Okay, everyone, I think we can start now. So I'll just project my screen. I hope all of you can view the screen, right? Okay, so this is the third uh, third lecture in the discussion series, right? So uh, today we'll be addressing the questions posted in the assignment number 3, right? So the first question which is posted in the assignment is a circuit has been given to you. I hope you all have gone through the assignments. Like, have all of you gone through the assignments? Uh, is there anyone who has gone through the assignment number 3, which has been posted on the net for you guys? Like, have you visited that particular website? Okay, it's like you have you might not have gone through it, but I'm very sure that you will go through it. But let me, for the time being, discuss the questions which are posted in assignment number 3, and we'll take it up from there. So, a circuit is given to you, and it is asked that you determine the value of IL, right? So how do you approach this particular problem, right? You approach this particular problem in the same manner which we have been approaching the last two times, right? We take the nodal voltage as voltage V, right? And we do the KCL analysis at this particular node. Let me call this node as node A, right, for the comfortability. So then voltage at node A is nothing but voltage V, right? So you write the voltage equation, like the current is flowing out here, 5 ampere current, so the current must be flowing in, right, to kind of to give out this value of 5 ampere current. So the 5 ampere current 5 is nothing but equal to like I can take this particular potential to be a ground potential, right? So I can write zero minus voltage V divided by 2 ohms, right? And then the other current will be 2 ampere 2 ampere current minus V by 20, right? And it's also given to you that the current 2I is nothing but equals to uh, the current not the current 2I, the current I is this current I which is flowing in this particular branch is the voltage across this particular thing is nothing but 2 times I, right? So I can write that it's given to me as V divided by 2 ohms with a negative sign because the current is upwards in this direction, right? Um that is nothing but I, right? As per the question, right? So if I'll take this particular this particular relation of between the nodal voltage V which we have assumed and the current I which has been given in the question, right? And then substitute the equation number 2 in equation number 1, we will get something like 5 is equals to I plus 2I plus I by 10, right? So you will end up with 5 is equals to 3.1 I, right? And from here you can determine the value of I, right? That is 5 upon my 3.1. And if you have this, then you can determine the value of IL also, because if this is I, then I know that my V is nothing but V is nothing but I by I into 2, right? From equation number 2. From 2, V is nothing but 2 times of I with a negative sign, right? So you can have the value of V as 10 divided by 3.1 with a minus sign, right? And then IL is nothing but V upon 20 ohms. This is your IL. So you solve this, you will get the answer as IL is equals to 0.16. I have done it, so I remember it kind of. So 0.16 amperes, and then that will be somewhere around in this particular thing, right? And you can then proceed forward. So is this solution okay to you guys? Like, did you understand this particular solution? Some of any one of you can unmute yourself, and if you have understood, you can just say yes, right?
Yes.
Okay, that's good. So the point is not the problem solving, right? You can of course, like, I am very sure that at this point of time you can of course write the KCL and the KVL equation and then solve it. I think why the person who has said the question is giving this particular question to you is he wants you to understand the significance of this particular thing, right? So it's a basically dependent source which is being given to you, right? So it's a, what kind of a source is it? Is it a current source or is it a voltage source? Anyone can answer. Just unmute yourself and answer. What kind of state is it giving? Is it giving you a current or is it giving you a voltage? Right. So tell me guys, what is this? Is this a current or a voltage? 2I. Is it a current or a voltage?
Current.
Current. That's good. And it's dependent upon what? Is it dependent upon current in some other branch or is it dependent upon voltage on some other branch?
Current.
Current. So you what do you have? You have a current source which is dependent upon the current in some other branch, right? So you have a current dependent current source, right?
Yes.
Am I right? Right. So basically the idea is you can have y is equals to kx, right? So where x is the dependent thing, k is nothing but a scalar quantity, and y is, sorry, x is the independent thing, mistake, independent thing. Y is the scalar quantity, and y becomes your dependent parameter. So in this particular case, I was your dependent parameter, right? The current which is coming out here, the current which is coming out here is your dependent parameter I, and it is dependent by a factor of 2. The scalar quantity is 2, and the thing which is it's dependent on is another branch current called I, capital I, right? So that is the thing which I think the person who has said the question wanted you to understand. That is this is how the current source behaves, right? It can be a voltage dependent current source as well, right? So it can be a function of anything, right? So it can be a function of some other quadratic thing. So you can have a current I here, right? You can have a current, let's say I2 here. IL is already given to you here, right? In that case, the author can write that let's say the current over here is not 2I, but it can be some I is equals to capital I plus I square plus IL by 2, right? This can be a very valid equation, right? And then the author can give you the relation between IL and I. So IL is, the author can write that IL is nothing but cubic root of I, right? So now he has given you a new equation of the relation between the current and the dependent quantities. The dependent quantities here are two, that is the branch current in this and the branch current in this, and the relation between these two branch currents are also given to you. Right, so it's up to the author's imagination and the circuit configuration, what kind of dependent currents and voltage source you end up looking in your question. So am I very clear in this particular question? Did you all guys understand? Okay, Ankita, did you understand? You can just unmute yourself and then say yes or no.
Yes, sir.
Okay, that's good. So feel free to respond, right, guys, because it will make the class more interactive, and then that would be healthy for our robust discussion. So in question number 2, the question asks you to figure out the potential between these two nodes. Let me call this node A and node B, just for the purpose of simplicity. So tell me first, is there going to be any current in this particular branch? Let me call it IAB current, right? Is there going to be any current in this particular branch? Anyone can
No.
speak. Sorry, I didn't get it. No, right? Somebody said no, right? Yeah, that's good, that's good. So there is not going to be any current, and the reason is very simple, because it's an open branch, so no current is going to flow through it, right? Okay, so what is the other current in the branch? 1 ampere current, right? And where is it going to flow? It's going to flow in C, D, E and F, right? This is going to be the path, right? So it's going to start from C and then terminate in F and then again come back to C, right? So and then the value of the current is of course going to be 1 ampere, because it's a fixed current source, so the same current has to flow in the entire loop, right? So if you know the value of current, can you figure out the voltage drops? It's very easy, right? So you start from here. Let me call it the node F, right? So if I'll take the node F to be kind of 0 for the purpose of ease. So if this is 0, I'm just rounding this particular node here. So you'll start with this node, then 0 plus 2 volt, right, minus IR. So what is I? I is 1 ampere, and the direction of current is like this, right? So you are going in the direction, opposite direction of current, so it will be plus. So 2 into 1, right? Again plus, because you're again going in the opposite direction of current, right? So 2 into 1, and this brings you to potential at node C, right? So the node potential at C is nothing but 6, right? From this particular equation, it's 6 volts. Okay, and how about the node potential at D? It's nothing but, from the very same logic, it will be equal to 4 volts, right? Okay, so what's going to be the potential across Vx? So no current is flowing in this particular branch, so I know that that the potential drop here is going to be 0. So I know that Vd minus 3 volt is nothing but Vx, correct? So from here I can get 4 minus 3 is equals to 1 is equals to Vx. So it's very simple. Like it's very simple. You can write it as a KVL equation, right? So what I have written here, Kirchhoff voltage equation. So I started from this particular node. I just started moving ahead, and then I started writing the voltages drop in this particular section. In this particular section, right? And then I use those equations determined by the KVL to figure out the value of Vx, right? So I think this question should also be clear to you guys now. Okay. Sushant, right? Sushant, you are here. Can you unmute
Yes,
yourself
sir.
and then mention if you have understood or not?
Yes, sir. I understood.
Okay, that's good. That's good. So this was a straightforward equation, like question based on KVL, right? Uh, Again, Sushant, would you try to kind of make a guess here? How to solve question number 3? So tell me, Sushant, like, is there going to be a current in this particular branch, I1?
No,
Sushant,
sir. No.
I1, there is going to be current in this particular loop or not, I1? There is a voltage source, 4 volt, 3 ohm and 5 ohm. Is there going to be a current circulating in this particular loop, Sushant?
No, sir.
Why do you think so?
There is provided sir voltage source.
Pardon?
Voltage source is provided, sir.
So current is going to flow in that loop or not?
No, sir.
Okay, Sushant, tell me this. You have a voltage source with you, right? Let's say of 10 volts, right? You connect it to a 1 ohm resistance, right? Current is going to flow in this resistance or not?
No, sir.
No. Why do you think so, Sushant? You have a 10 volt resistance and you connect a 10 volt voltage source and you connect it to a 1 ohm resistance, then the current is going to be 10 volt divided by 1 ohm is equals to 10 ampere, right, Sushant?
Yes, sir.
So why do you say that no current is going to flow? Current is going to flow, right?
Yes, sir.
Okay, TK, you just revisits the concept there. Current is going to flow in this particular loop, and I've just labeled it as I1, right? And on the similar lines, current is going to flow here as well, right? But in this particular section, is there going to be any current flow? Let me call it I3. Anybody else can answer? So just let me see. All of you guys are here. Okay. Anyone can take a guess there. Bulan, are you there? Bulan?
Yes, sir.
Okay. Do you want to take a guess here? Is there going to be any current I3? Bulan?
Yes, sir.
Is there going to be a current in the branch I3?
Yes, sir.
Why do you say so, Bulan? See, if I have a voltage source with me, right, and I connected the in case 1, you have case 1 with you, where a 10 volt voltage source was there with you. You have the positive and the negative terminal with you. So any current which is exiting must find a way to the negative terminal, right? So somebody has
Yes, sir.
responded, no, there is going to be no current in branch 3 because it is an open circuit. That's right. But let me just explain. So any current which is leaving the positive terminal must find a way back to the negative terminal. If that is not the case, then it is known as an open circuit, basically. So if same case 1, I'm just deriving a case 2 based on the case 1. So you have a 10 volt voltage source, you connect it to a 1 ohm resistance, but you don't connect the negative terminal to the other end of the 1 ohm resistance. It's open ended, right? So in that case, no current is going to flow. The reason is that current once exits from positive terminal must find a way to the negative terminal. If that is not the case, it is open circuit. So whoever responded that it's an open circuit, no current will flow, is correct, and the reason is the person has mentioned in the, there is something wrong with the power. Just give me a minute. Okay. Sorry for this disturbance. The power adapter was coming out of the plug. So I hope that it's correct to you, right? So in this particular case, the current, if it is leaving from this positive terminal, right, cannot find a way back because this is a self loop, right? So if current goes here, it cannot come back to this particular node because this is not connected. If these two nodes were connected like this, then it would have come back, right? It would have found a way back, but it's not connected, and therefore you cannot you cannot have current I3. So how to solve this particular question? This again becomes a very simple question because there is no current flow in this particular branch. So whatever the potential here is going to be the potential. It's not going to change, right? The potential of the battery is going to be the potential in this particular branch. So just for the sake of simplicity, again we'll take one ground potential here and keep the other things ungrounded, right? So one ground in the entire network. And then try to figure out what's the potential at this particular node with reference to this particular ground, right? So the potential at this particular node, let me call it VA, is 5 divided by 5 plus 3 into 4, right? So that is 2.5, right? I hope it's very clear. It's based on voltage division across resistance, right? So you have 5 and 3 ohms given to you, right? You can figure out the voltage across these two resistance using the concept of voltage division across resistance, right? So I'm hopeful that, like, I have taught you this particular thing in the previous class. I'm sure that things has been covered in the regular classroom with the professor as well. So if you are not sure what is the voltage division across resistance, feel free to visit the professor's lecture. He'll be teaching you there, right, in the first and the second and the third lecture as well. So you have the potential at VA, right? And once you have the potential at VA, you can simply write that potential here, right? Let me call it VB. So the potential at VB is going to be VA plus 3 volts is equals to VB. So this is nothing but 5.5, right? And this is VB, right? But then I also know that there is going to be some current flow in this particular branch, and it's going to be isolated from the current flowing here. So what's the current flow here? It's nothing but 5 volt divided by 4 plus 6, right, ohms. So it is nothing but 0.5 amperes, right? So if it is 0.5 amperes, then VB minus 0.5 ampere into 4 is giving you V1. So VB was 5.5 and this is minus 2, so this gives you 3.5 is equals to V1, right? Now you have your V1 with you and the V2 I have grounded it, so V2 there is no potential, right? And then the question asks you the difference between V1 and V2. So V1 is 3.5, V2 is equals to grounded, so this is equals to 0, so V1 minus V2 is 3.5, which is given as option number A, which is your correct answer. So the thing which I wanted to kind of impress in this particular question is that you must understand the concept of open circuit and closed circuit, right? So the moment you identify that the circuit is open, no current is going to flow, and then you can just truncate that particular branch and solve the rest of the circuit, finally figure out the voltages at different nodes using the solved equations, right? So I hope that question number 3 is now clear to you and you have understood the concept of open circuit and closed circuits. Okay, then comes question number 4 or 5, whatever it is. Okay, this was 4, right? 1 2 1 2 oh, 3. Okay, something is missing. Nonetheless, this question asks you to figure out the power which is absorbed in 8 ohm resistance. Okay, so where is the 8 ohm resistance here, right? So what's the power absorbed in 8 ohm resistance? In terms, can I write it as I square R, right? So current which is flowing in the 8 ohm, that thing squared into the resistance R, R is nothing but 8 ohms, will give me the value of the power which is being dissipated in the 8 ohm resistance, right? I hope that this is very clear to all of you guys. So the only thing which is left out is, like, given that I know this particular equation, the only thing which is desired now is the current which is flowing through it, right? Through the 8 ohm resistance. So I need to figure out what is I 8 ohm, right? This I need to figure out. So for this, let me just ask you what should be the easiest method of solving this particular question. How would you approach this problem? Anyone can take it, take a shot here. Okay. Feel free, guys, to speak up, man. Like it would be great if you are kind of having some kind of interaction, right? Shiva Sheshan, like I don't think I'm pronouncing your name correctly, but then if you can understand me, Shiva Sheshan.
Trying to understand, sir.
Yeah. So am I pronouncing your name correct? Shiva Sheshan. Shiva. Shiva.
Sir,
Yeah. So can you hear me, Shiva?
sir, yes, sir, audible.
Okay. So would you want to take a guess over here, Shiva? Like how would you solve this particular question? How would you figure out the current I8, the current in 8 ohm resistance? How would you do that? What should be the way forward?
V square by R.
That is all right. That is the power. So how would you, that V by I is the current in the 8 ohm resistance, right? Or V square by R, you are saying that means you have to figure out the voltage across the 8 ohm resistance. Am I correct, Shiva?
Sir, yes, sir. Can we reduce the network, sir?
Reduce the network.
Yes, sir.
How do you propose to do that?
Don't know, sir.
Okay,
To...
let me help you, Shiva. Let me help you.
Thank you, sir.
So So the easiest method, like you need to solve few questions to understand what should be the easiest approach to a problem, right? These kinds of problem would be appearing in your regular class examinations as well as in future competitive examinations as well, like after your undergraduation, whenever you are writing for your masters or any kind of examinations. So you need to have a sufficient understanding of circuits to identify which thing to apply when, right? So here clearly a node is visible to you. This particular node is visible to you, right? And I wanted, this is the power which is there, right? So this easiest thing which is like apparent is that you figure out the KCL at this particular node, right? So you take the node voltage as voltage V, right? And proceed on from there, right? So the node voltage is V, right? So the current, let me just say the current will be flowing like this, current is flowing like this, current is flowing like this, and current is flowing like this. So IA, IB, IC, ID. So I know that IA is nothing but IB plus IC plus ID. As per the diagram I have drawn, this is the direction of the current, right? This is the direction of the current I have chosen. Based on this, I can write the KCL equation like this, equation number 1. Now IA is given to me as 2 amperes, so no worries there. What is IB? IB is nothing but V minus 10 divided by 3, correct? So you took the voltage as V and you subtracted 10 volts from it, you divided by 3 ohms, right? And then that becomes your IB. Now what is IC? Somebody else wants to take a guess? Maybe Shiva, you can help me here. Shiva, what is IC?
So 6V minus 8 ohms. So,
Right, Shiva. Proceed on. 6 you are saying, right?
so 6
Right.
minus 8
6 minus 8, okay. And then
by 2.
by 2.
By 2.
Why do you say those? Say show Shiva. See, this node potential is
That's a
V.
voltage source.
Node potential is V, right, Shiva?
Yes, sir.
Okay. So how do you figure out current? You find the potential difference, right? And you divide by the resistance. This is the formula for finding out the current, right, Shiva? You figure
Yes,
out
sir.
what is the potential difference and then you divide it by the resistance, right?
Yes, sir.
Okay. So what is the potential difference between these 2 points? This point here and this point here.
V minus 2 by 8.
V minus 2 by 8. And how about the 6th thing? 6 is also here in the picture, right? So I can write, tell me if I'm correct or not, Shiva. So you have a voltage V, right? Minus 6 volt,
Okay.
right? And then minus 2 volt and then divided by 8 ohms. Is this correct, Shiva?
Sir, I have a doubt, sir.
Right. Bolo?
Sir, why minus it, sir?
Right. So when you are going in this particular side for figuring out the current, right? So the first thing you encounter is a voltage source, right?
Yes, sir.
So what is the drop in the voltage source when you travel from this, like this node? I know the voltage is V, which I have given the designation as V. What is the potential at this particular point? Let me call this point as E, right? So what is the potential VE?
Okay.
It's V minus 6. Correct,
Oh.
Shiva?
Yes, sir.
Right? And then what is the,
Yes, sir. Understand.
understood, right? So V minus 6 and
Yes,
then
sir.
minus 2 divided by 8 ohms will give you the current here, IC, right?
Okay, sir. Yes, sir.
Okay, that's good, Shiva. Like, can you help me figure out what is the current in ID branch, Shiva?
Yes, sir.
Bolo?
V minus 20V
and then
by 4 ohms.
by 4 ohms. That's good. So
Yes, sir.
so this equation, this particular equation has been derived using the equation number 1 mentioned over here, right? So now you have a simple equation in voltage. One equation, one variable. Can you solve it, Shiva?
Yes, sir.
One equation, one variable. You can solve it, right?
Yes, sir.
Okay, that's great. So once you have solved it, can you figure out the value of IC, Shiva? Let's say you get the value of voltage as, let's say, hypothetically speaking, I've not solved it, but then let's say after solving it, you get the value of voltage V as 10 volts. I'm not saying that the voltage V will come out to be, I'm just saying that hypothetically it comes out to be 10 volts. Then what is the current IC?
No, sir. I see.
So you know this is the equation of IC, right? This is IC, right, Shiva?
Yes, sir.
So you
Yes,
just
sir.
substitute the value here. 10 volts minus 6 volts minus 2 volts divided by 8, right?
Yes, sir.
Right? Very obvious, right?
Yes, sir.
And what is IC? IC is nothing but I 8 ohms, right? This is the current which is flowing through
Yes, sir.
8 ohm resistance, right? Then you square it and then,
0.2 amp.
right, 0.2 amp, right? And then you square it and
Yes,
then multiply it by 8 ohms to get the value of the power, right? So for getting it, you need
Yes,
to
sir.
first figure out what is the value of voltage, right? Which can be obtained from solving this particular equation, right?
Understand, sir.
Right? You solve this particular equation here. You solve this equation, you figure out the value of voltage, and then you take this particular equation and then you solve it. So what I want you guys to do is go back and then solve these questions once again, right? If you are not solving it, just hearing it out won't help you guys. So you need to solve it. And then if you have any problems, you can again watch the video. It's available on YouTube anyways, and then it will be helping you guys to have a better understanding of the subject, right? Okay, let me go to question number 6 over here, right? And the question asks you to determine the value of Ix. Now, what is Ix? Ix is the current which is flowing in the 12 ohm. This is the Ix, right? The one I have circled in red. And tell me, guys, what kind of voltage source is it? This particular thing. Is it first a voltage source or a current source? Do you see any dependent sources in this network? Anyone? So the person who is named as 2012, right? In the meeting today, 2012, the name is not mentioned. It's the numeric value is mentioned 2012. Can you unmute yourself and then speak? What kind of source is this? Is it a dependent or independent source?
Dependent, sir.
Okay. May I know your name?
Venkatesh, sir.
Venkatesh. Good, Venkatesh. So it's a dependent source. What kind of dependence it has? Is it a voltage dependent source or it's a current dependent source?
Voltage, DC voltage source, sir.
DC voltage. It's giving you out a DC voltage, right? But it is dependent on?
Yes, sir.
It is dependent on current, right? Venkatesh?
Oh, okay, sir.
Right? So it's a voltage, it's a current dependent voltage source. Am I right, Venkatesh? It's dependent upon current,
okay,
right?
sir.
Current, Ix, current, right? So it's a
Okay, sir.
current dependent voltage source, right, Venkatesh?
Okay, sir.
Current dependent voltage source. Okay. How would you find out, how would you approach this problem, Venkatesh?
I don't have idea, sir.
Okay, that's good. That's good. I'll help you out here, Venkatesh. No problems.
Okay, sir.
So, whenever you see this kind of
Excuse me, sir.
problem, right? The first thing which should come to your mind is what should be the easiest approach to solve this question, right? So the easiest approach, like which I'm figuring at this point of time, is like KCL seems to be the most obvious, right? So I see three nodes, this node, this node, and this node. I can name them as VA, VB, VC, right? And then I can try to write the KCL equation at that particular point. I will have three equations, three variables. This is what I'm going to end up with, right? And once I end up with that thing, right, then I can easily solve it, because like I know what is Kramer's rule. So this the other option would be to algebraically solve it. You are free to solve it, like you have like three simultaneous equation in three variables. You can solve that to get the value of each variable, or you can utilize what is Kramer's rule, which I had taught to you in I think lesson number 1, right? That will kind of simplify the things. You can use Kramer's rule and then figure out the value of each variable, right? So just let me write the equation for the sake of understanding here. So at node A, right? So I'm writing at node A, 12 ampere current is coming, right? And this is exiting as 18 ampere, right? Plus VA minus VB divided by 12, and then VA minus 0 divided by 4, considering that I have grounded this one. So this forms your equation number 1. So did you understand this, Venkatesh? You can unmute yourself and say. Say again, Venkatesh.
Seeing, sir.
Okay, you are still seeing it. Okay, I think there is a lag at your end. Okay, no, not a problem. You will be able to see it in some time once the lag is over. So this is how the equation number 1 is derived at node number A, right? At node number B, what you have is VA. I have the current in this direction, right? So current now flows out here like this, and this like this. I've taken it like this. I've taken the designation which is there appearing on your screen. So VA minus VB divided by 12 is equal to VB minus 36 divided by 6 and plus VB minus VC divided by 15 is equals to second number equation. Good. Okay, and then at VC, what will be the equation at VC? This particular node, it will be VB minus VC divided by 15 is equal to the current. Let's say the current here is this I 5x, right? 5 times Ix, sorry, 5 times Ix, and then okay, that's just the potential at that node. Let me just call the current as Ix. Ix will again cause confusion, so let me name it as Iy for the sake of simplicity. Iy, and then the current which is flowing out is minus 24 amperes, and this forms your equation number 3. That's great. So now you have 4 variables and 3 equations. You cannot solve that because you are the constraints are less than the number of variables, right? So you need to have one more equation. Not a problem there. So how can you get that? You can get that by using what's given in the question. What's given in the question? So the potential at C is nothing but 5 times of Ix. Okay, that's given to you. Good. But what is now Ix? Ix is nothing but 5 times of VA minus VB divided by 12, right? This is your Ix from the equation number from this particular circuit, right? So you have now the fourth equation with you. So once you have this, then you can kind of solve it. 4 independent equation, 4 variables, you can now solve it, right? So what are the 4 variables? These are the 4 variables: VA, VB, VC, and the current IY, right? So 4 variables, and then 4 equations. You can solve this equation and then figure out the value of IY. Once you figure out IY, you can figure out the rest of the things, right? That is Ix also can be determined, right? So did you understand everything here? Like once you have the solution of these 4 equations, for 4 equations, 4 variables, you solve them to get the value of VA, VB, VC, IY. These are the 4 things which you will get, right? Once you have these 4 things with you, you can get the value of Ix. Why? Because Ix is nothing but VA minus VB divided by 12. So you have the solution of VA and VB from this. You substitute it here, you divide it by 12, you get the value of Ix. It will come out in this particular range, hence it's marked here. So the correct answer would be B, right? Did you guys understand this? So Venkatesh, did you understand this particular solution?
Yes, sir.
Okay, good Venkatesh, good. So let's say Venkatesh, I ask you that what is the power which is being dissipated in this particular dependent source. Would you be able to tell me that, Venkatesh? Venkatesh, how would you determine the power which is flowing out of the dependent source? Feel free to unmute yourself and then say whatever comes to your mind. If nothing comes to your mind, you'll say help me, sir. Not a problem there.
Help me, sir.
Okay. The power which is flowing out of the dependent source can be written as the voltage into current product, right? Right, Venkatesh? Power is voltage into current, right?
Yes, sir.
Okay. And what is the voltage there, Venkatesh? What is the voltage?
36 voltage, sir.
Voltage is 5 times Ix, right, Venkatesh?
Yes, sir.
Right. So 5 times Ix is the voltage. What is the current? Current I have taken it to be Iy, right? And flowing in. So the current which is flowing out will be minus Iy. So this is the current, this is the power which is flowing out of this the dependent source, right? Or if you will take plus Iy, then it will be the current which is flowing into the dependent source. So it will be absorbed, right, Venkatesh? Okay, maybe I'll help you out here. So the next question is based on this very fact, right? So this same concept has been repeated, I think once back as well. So in the next question, the question asks you to determine the power associated with the dependent voltage source, right? So here you are also going to do the same thing, right? You figure out the power. You know that the power equation is voltage into current, right? And you know that voltage is nothing but 5 times Ix, right? And the current I had assumed in the like this is the same question, same values, everything is same. Just the part is different. Like they are now asking you to figure out the power, right? So I had taken the current in this particular branch as Iy, right? So the current I is nothing but Iy, and then I'll write it, since it is flowing into the circuit into the positive node, so I'll write it as absorbed. If the multiplication comes out to be positive, then it will be positive energy absorbed. If it comes out to be negative, then it is kind of delivered. So the current direction would be ulta, right? Delivered. So based on the value of Ix and Iy, right, you will be able to figure out the power involved, right? So how to figure out Ix and Iy? The same thing, like you have already the 4 equations with you. Once you solve these 4 equations, you will be able to figure out what is Iy and what is Ix. So here is Ix and here is Iy, right? So you have 4 equations with you, you solve them, you figure out the value of Ix, Iy, then put it there in that particular equation which I had mentioned. The equation was same as this over here, right? Which I was just talking a little while back to someone. So you put this equation in this, you put the values of Ix and Iy in this particular equation, and then you will be able to figure out the power, right? So it will come out to be the total product is going to be a negative product, right? And it's going to be kind of a delivered power, right? Because it's negative, therefore it's not absorbed, because if the direction was like this and then everything was coming out to be positive, it was absorbed. But you will figure out that it is ulta actually. So if it is ulta, that is the current is actually flowing like this. Current is actually flowing like this from here. So once you figure out Iy, it will be in the opposite direction, and therefore it is power delivered, right, not absorbed. And then you figure this out, the numeric value associated with this, it will be in this particular range, and then you can check the answer, right? So this is how you solve this power absorption. Same question was there, similar type of question was there in lesson number 1 as well. So feel free to visit lecture number 1 and then the one which I had taken, right? And then you will be able to figure out a very similar problem in that lecture as well. So I am hoping that this is clear to you all, right? Is this is the problem clear to you? One of you can unmute and then say yes or no, or if no, then what is not clear to you?
Yes, sir.
Okay, then that's good. Let me just proceed forward. So in this circuit, it asks you to figure out the power associated with the 10 volt source and 18 ampere source. Okay. So this is again the same thing. You have to figure out the power with 10 volt and 18 volt. So power is nothing but voltage into current. This I know. So where is the 10 volt? 10 volt is here. So I can assume that the current which is flowing out is I10, right? And I can assume that the voltage at this node is nothing but VA. Let me just say VA or VB, because the second node. So VB, and then I can ground this, right? So power for 10 volt will be 10 volt into I10, right? This is the power. What is the power for 18 ampere? It's potential VA, VB potential into 18. So is this correct, guys? This is how you will find it, right? You just take the voltage, you take the current, you multiply them together, and then you figure out the power, right? So I think I think it should be obvious to you by now, right? Then how do you figure out the individual things? Like how do you find the numerical value? You take again the KVL and the KCL, like those things are going to remain the same, right? So you have three nodes with you. You have three nodes with you, VA, VB, and VC, and then you write the equation, KCL equation at these three nodes. So it will be nothing but uh, VA is nothing but 12 volts. It's given to you, right? So so if this is given to you, then not a problem, right? This is given to you, that means you have this current and this current as well. So if this is given to you, then I can write that the current which is, it's not this is not asked what is the current which is flowing out here, but then you can figure this out as well once you have this current and this current, right? So this is VA, I'm writing at node B now, right? VA minus VB, right, divided by 8 is equals to 18 ampere, right, plus I10, right? That is the KCL at node B. Okay, 18 ampere, I will just write it as 18 to avoid any confusion. And then I'll write the same thing at node C. So it is nothing but I10 is equals to VC divided by 6 minus 24, right? So you have this particular equation, right, at node C. Okay, how about like are there any more, how many variables are here? VA, VB, I10, and one more variables are there, right? So there is two equations with you and four variables are there with you, right? So where are the other variables going to come from? Any guesses, guys? Any guesses? Okay, if not, then I'll tell you. So here in this particular node, like I had mentioned that this potential is fixed to you, right? So here I had mentioned that VA is 12. So one thing is simply clear to you, that VA is 12. So one variable is gone. Not a problem there. So you are left with three variables and two equations, right? So that thing also can be resolved because I know that just give me a minute. VB minus VC is equal to this is in this direction. So VB, I can write VB plus 10 volt is equal to VC, right? So VB minus VC will be equal to minus 10, right? So this gives you equation number 3. So you have three equations, you have three variables, you solve them, you figure out the value of these things. You use these fundamental equations of power, you substitute the value in these two equations, you will get the value as D, right? So it will be absorbed in 10 volt and 18 ampere both, right? And similarly you can figure out what is the power which is there in the other voltage and current source. So you can figure out what is the power absorbed in 24, you can figure out what is the power absorbed in 12 volts. You can figure out the rest of the things once you have the solution of these. So I'm hoping that this is clear to you, right? If you have any doubts, please report them back when you get back next time we meet, right? And I'll be here to address them. I'll request you guys to please kind of solve these questions on your own, right? If there are any problems you are facing, please feel free to view the lectures again. It is available on YouTube. Practice as many questions as possible, right? It will help you get a better understanding of the things, right? So with that, I'd like to conclude this session, right? So I'm stopping the